kilogram level, another was a little bigger, and then they are building one more. But what you saw that everything was on pyrolysis. Okay, and they are taking lot of more waste and all. And they are trying to build a bigger facility where they can demonstrate good amount of oil, which can be used as a sample for further application and testing and other things. If you do at the gram level, we don't get enough material, testing engine or fuel or anything, but we do more research. But it's a kind of transition, okay, lab to bench, bench to pilot, pilot to machine. That's the state we go. And what you see there, that's a facility. Okay, you can do so many other things. Like I said, I was telling that it's good for the refraction. It's a reactor, fixed bed reactor, continuous reactor, or a reactor. You have to take it like that. But the idea was a very good connection because we had talked pyrolysis a day before, and then you could see in action and you could see the sample, you can touch the samples. Okay? So while it's a very vast topic, hundreds or more than years of work is there. My work is also more than 10 years, and everyone is working, so it's very difficult to cover in 3 or 4 days. Okay? The idea was to start the discussions, bring these topics here, what we are working. Today this is my last session, and we have done a little longer, but this one I'm just trying to see where we stand. Okay, and again we make interaction. So carbon capture and storage, we talked, and this is kind of a need of the hour. Many projects are going on, and you can see that carbon capture and storage is called CCS, but we moved from CCS to CCUS. What is the difference between CCS and CCUS? So yeah, CC is carbon capture, U is utilization, and the storage if you need or sequestration. So we started with the storage, and there are many places you can just store. It may not be possibility of utilization, but wherever we have, we should do CCUS. And if you are doing CCS power plant as the biggest emitter point source, you have to find out. Okay, disperse non-point is difficult, but if you have a point source, then you can implement 2 things. Right. Power plants are the point source. Okay, we have burn coal or natural gas and CO2. So that's where we should focus. So post-combustion, oxy-fuel and pre-combustion, there are 3 different approaches how you can reduce CO2 emission in factory. Right? So kind of process engineering or more there to do that CO2 can be emission is less. Oxy-fuel combustion is oxygen, otherwise it's managed. IEA, how many you know IEA? International Energy Agency. Okay? And they look at fossil and both sides. Okay? So their prediction is iron and steel by 2030 CCUS 4%, 2050 25, 2017 and 2025%. We are talking carbon emission and we are talking bioenergy, and I am showing iron and steel. What the connection? Because iron and steel needs a lot of heat in the process, furnace, kiln and other things. That's a CO2 emission point. So can we reduce that? It's not just thermal power plants. There are many other places where we need a lot of CO2. Cement, kiln process. So there also we are targeting chemical industries. There are many industries where carbon intensive. So we are looking at it. We have started with fuel, fossil fuel and road transportation, but we realize that industrial decarbonization are equally important. And this is part of industrial decarbonization. Fuel definitely, power generation is definitely. So global funding trends, you will see that blue hydrogen, ammonia, natural gas processing, BECCUS. What does it mean? Bioenergy, carbon capture, utilization and sequestration. One of the example you saw yesterday, bioenergy, pellets, carbon capture, jar, utilization, if you are making filter or somewhere or some chemical, or oil we are talking you can burn or they are extracting some chemicals from the oil. So that's utilization, and S is the storage or the extraction. So you saw the ECU, CCUS in action yesterday. When we teach in class, it looks like what's going on, right? But this is simple to understand. A lot of focus is gone on bioenergy side. Some of the startup, there are many more startups, but some of those are here. Green light carbon technology, direct air capture, that's biological sequestration. CO2 utilization in concrete, cement I was talking, sir. Cement industry is also heavy on CO2 emission. So bioenergy, biomass gasification technology have improved efficiency. Like BEC, CCUS, where I say you can gasify, pass to Fischer drop, and you can make it fuel. When we are talking fuel in the future, we are talking drop-in fuel, not much blend fuel. Focus is shifted more on drop-in fuel. And biomass gasification gives you drop-in fuel opportunity. So you produce syngas, pass to Fischer drop, and you will get diesel, which is as good as petroleum. Lot of focus on biomass plus other feedstock also. We realize that there are many more than just biomass, food waste, paper waste, and other things. So non-traditional biomass sources like municipal waste are increasingly explored wherever you find. That's why we call this organic waste, this thing was. These are numbers I don't go there. In India, you will know better than me, but I try to list it what's going on. India is the fastest growing bioenergy market globally, and energy expected to account for 45% of total energy consumption by 2030. Policies such as mandatory blending obligation for compressed biogas and all blending target 20% by 2025 or 26. Now you can yourself answer point 2 where we are saying that 20% will be mandatory. Are we there? I don't see here. I don't know. Some states might be doing, but it's not mandatory. These are optional. So we set the target, the same in across the world. We try to meet it. If not, then we extend the timeline. Because saying it's easy, but are we able to produce that much? If you don't have that much production, then how to do 20%? CCUS is growing here. Initiatives such as National Biology Program, SATAT, and to promote bioenergy is going on. Emerging carbon. Industrial decarbonization focus is also come, not just transportation. Industrial decarbonization is steel making, cement making, paper, which are the high, one source of CO2 emission. So CCUS are being done. This one yesterday, day before yesterday, I was saying, don't have to be, there are the startup ideas here, right? Not just research, fuel and all. There are a lot of opportunities. So Ministry of Power in 2021 took a guideline that thermal power plants should have 5% of renewable in that. Now we see steel, cement, all these industries they need energy. And natural gas or coal was the source. They are mandated to do 5% of renewable or biopower or waste, organic waste power. You will see that NPPC, they have most thermal power plants, right? So they are running around there to get this bioenergy, 5%. They have to get how to implement in their system. 5% is 95% goal, 5% biomass. But you will have to develop an engineering system, right? Boiler designed for coal only. Now you are adding 5%. 5% may look less, but it's a huge amount if you look at the scale of power plants being operated. That much organic waste or biomass needs to be arranged. Now what is best with blending for coal? We discussed before. If you want to do co-firing, this is an example of co-firing, not direct firing, you can say that. So, what is the best way to blend biomass with coal? If If you take sawdust powder, which we saw yesterday, so many chips, so mix with coal, will it mix? Put in conveyor belt and fly it. It will separate them, right? You need pellets. Just for transportation engineers also, you need pellets. Now you have choice, raw pellet, biomass pellet, or torrefied pellet. Alright? Raw pellet, everyone knows they can make it. Torrefied pellet, Manipal University can make tomorrow, but not many places. Right? You need to have a facility. Torrefaction. Torrefaction is low temperature powerhouses. So now the startup or business part of it, many companies want to go in this direction. Can they make pellets, torrefied pellets, torrefaction plant? I know one or two companies they set up quickly and they develop a 10 ton per day plant already. And power plants need assurance. Let's say tomorrow they started 95 and 5% ratio, and after 6 months they cannot find 5%. Then it's not going, alright? It's short term. So those kind of things, business opportunities are there, but you can get a contract and you can be sure on inventory, that's the opportunity. So torrefaction, why torrefaction? Because it gives you 1.3 times the energy density. When you transport, you are transporting more energy. When you are blending with carbon and coal, you are blending more energy into that, and still it is cleaner. So this is easy business and lot of demand. With 5% you will do calculation, lot of amount of biomass is needed. This is how the refined biomass will look like. Gasification, if you remember I was talking about syngas can be fermented. Carbon monoxide and hydrogen can be fermented to make ethanol. Looks little weird. Normally fermentation is liquid, right? But syngas can also be fermented. And if you go to gasification route, break down all organic biomass in syngas. There is no lignin or this and that, right? So it's 100% carbon gone into syngas or CO2. And you clean it and then methanol. So efficiency looks better. If you go biochemical route, then you need to do pre-treatment, lignin will not take part in sacrification, those kind of things. So Landertech is the company. They mastered gas fermentation technology. They have their proprietary microbes, and that's where they built it. So I think they are leader on that. Waste to biofuel, sustainable aviation fuel from municipal solid waste. So what is sustainable aviation fuel? Have you heard about that? Aviation fuel, you know aviation fuel? Jet fuels. It is different than diesel. It's a diesel range but tuned for aviation. So suddenly or not suddenly last 5 years focus has shifted more on sustainable aviation fuel and marine fuel. Shipping, that industry. The road transportation fuel is kind of getting secondary more on aviation. The reason is you are getting lot of electric vehicles. So the growth might be shrinking. May not need that much biofuel, ethanol, because if everyone goes in electrical and electric in next 10 years, your opportunity getting lower. But in aviation, I don't see we are going to electric anytime soon. So jet fuels are needed. And jet fuels, if you go through sustainable aviation fuel, we call it, then it's coming from biomass and renewable. So SAF, in short, is called SAF. And lot of companies are working on family with organic feedstock to make SAF. Same thing for marine. Huge shipping. You see that container and big ships you will see in ocean. They are not powered by electric, and I don't see that much powered electric. So again, marine fuel and SAF are the opportunities where companies are. Coeds biofuel, Coeds, the company is a big ethanol company, monopoly kind of thing in United States. So they are gone to ethanol, but they are building plants where corn, stover and other grassy material can be used. These are the major companies working. So Landertech process, you get syngas gasifiers. You will have a gasifier. You get syngas and then compress, and this is a fermenter. And that's their proprietary microbe. And what you get is ethanol. But now ethanol, we say that in future we want jet fuel more than ethanol. So there are processes coming up, take ethanol and convert to jet fuel using catalytic process. So there are many companies taking the second part of the startup. They are focusing on ethanol to jet fuel. ETJ they call it, ethanol to jet fuel. European companies, they have Neste, Clariant, UPM Biofuel also, one of these here. Yeah. So diesel, I was saying a lot of focus was on biodiesel. Sometimes biodiesel is still biodiesel, but again, if you want to rely on future, we want drop-in fuel, not blend biodiesel, not biodiesel, 5-10% is fine. So how do you make drop-in diesel or renewable diesel? If you remember, biomass is hydrogen efficient. You take oil, and this oil, this is coming from paper sludge, but this oil can come from any beach, waste cooking oil, seeds which we don't eat, non-food vegetable oil. Do some cleaning, put to the hydro treatment, means hydrogen plus catalyst, upgrade it, it comes to the fuel grade, fractionate it like a distillation, and you get diesel. This is also commercial process. UOP is a huge company, they make it in Europe. So they have proprietary catalyst here, so that's why they make a lot. So anything greasy material, oil material, LGU including LG, you can put it here and you can get it. Department of Energy and many other departments, many other agencies who work on energy, they are looking at aviation and marine sector. We are looking at ground transportation. Again, I said here we are looking a lot of ethanol, blending 10%, 5%, but in next 5-10 years it's going to sit. But answer is coming for ground transportation because of batteries. But there are no answers coming for jet fuel or marine fuel. So if you are looking at the future, researcher will look for future, this is the way to go. Either biologically and all, focus more on aviation fuel or marine fuel. And they all have benefits of reducing greenhouse. This is the target for United States, 60 million gallons they will get it. Indian companies, Praj. How many of you know Praj? Pune based, you will know. Yeah, you know. So they are ethanol company and kind of monopoly here in India. Everywhere you see Praj technology they have. So they work on ethanol. It was sugarcane, now sugar bagasse and all the agriculture residue they are focusing on. So they might have their own enzyme and cocktail of fermentation and other things, but they are a huge company to follow. Indian Oil have a dedicated biofuel division, but they are on thermochemical process. So Praj is more on biochemical, this one is thermochemical. Reliance is more on thermochemical, but they also do. Biogas, energy, compressed biogas. So these are the company leading here. CCUS, carbon capture, Tata Steel focusing on steel production process, how to reduce. I know some other sector also they focus on how to reduce carbon emission. Indian Oil has CCUS, so CO2 to methanol. This is utilization. You capture CO2 and convert CO2 to methanol. CO2 to methanol have many different processes to do. One of them is electrochemical reduction. You can do that. Okay? And that's again not commercial process, but it's quite advanced. Pilot stage has been shown. So future researcher, we are focusing on non-food feedstock. If you are working on food based, that's not a future issue. That's not a It's called fourth generation. We started first, second, third, fourth generation. But nowadays, first generation or advanced. If you say advanced, it covers third, fourth, it's not to get confused. So always keep advanced generation and pyrolysis, gasification or digestion route. Anything you can capture CO2, you capture sequester or make fuel, go to hydrogen, methane, synthetic biofuels. We talk what are the different processes, but that's kind of the black box. We start from here, advanced feed stock, and you get drop-in fuel again. A drop-in fuel in this case will be SAF, sustainable aviation fuel, renewable diesel, those kind of things. Ethanol is good to go, but then you have to move ethanol to ET2 production, ETJ production, ethanol to jet fuel. You will see many companies coming on ethanol, so I'm not saying, but as a researcher, they are looking down the line 10 years or 20 years. That's the future. So challenges is cost, especially in existing plants like Tata Steel, they are trying to do, Reliance, Adani Group, or many other groups, so IOCL and other things. They have existing facility. Now they have to set up something to do that. So cost comes, how big a scale comes. So that depends on how much government support financing comes, how much they can take on. The CCUS project consideration rates exceed 78% due to high capital cost, and that is true. Many CCUS projects in United States started really big and they ran out of ideas or money, so that's a struggle. And just because of cost, you are adding cost to existing process. Biomass prices may rise 20% by 2030 due to competition for non-traditional feedstocks. So everyone is running around money to municipal solid waste now. Even if it is free, you have get money for hauling, but it's not going to be true. We are moving for jet fuel and all, we need to have a whole lot of methods. So the cost will come. The more we grow, it won't be free. Collaboration opportunities are there. There are many industrial clusters, there are many big projects in Europe where they have a consortium, US also has consortium, so there's a lot of opportunity there. So if you want to look at the United States sites, what they are doing in Department of Energy, you should be looking at, just look at this program. Okay? All technology what I am talking, they are listed there. The processes, more detail, what projects, whole lot of details are there. What they funded over the time. It takes time to dig in there, but you will find everything, most of the things. Their program area is the renewable carbon which we are talking. It's a general thing. Then they go more detail on conversion, CO2 utilization, bioproducts is another focus. Definitely bringing AI, ML, data simulation, other thing. Integration, system development. System development means I develop a process for fermentation, the other one is how the logistics will come. So how the entire system will look like. That's a big thing. Transportation fuel is moved to SAF and marine fuel. So here is the link, even if you have it or not, you remember this biotechnology office, DOE, Google it. I was talking, you are looking for postdoc position, future and all. Any funded project gets listed here, announced there. That's where you can see, okay, this group, this company, this professor got funded, so that's where you look at that. So maybe good idea to have RSS feed of this. Just subscribe weekly, monthly, and you will get it. Go to this website and they have RSS feed. New company, what updates, even if you are funded, any path-breaking results came out, these are announced, major publications. So this is a good resource, kind of one place to see a lot of things. India also have their own site and in NITI Aayog site and many other places, but this is much bigger than that. That's much I have today, and leave it for discussions. And I really enjoyed this and many more than this. Okay. questions. We have another 15-20 minutes. I see lot of enthusiastic researcher here, early, mid-career, academia is done, very much focused on environmental. So I really enjoyed your utility, interaction, and the idea is continue networking. That's building our team. If you need anything, just email me. I'll try to answer as much as possible. Yeah.
So, ethanol to budget.
Yeah.
So, what is the status now?
So ethanol to jet fuel go through dehydration process. So it's a thermal process and catalyst, and that catalyst comes as a proprietary or innovation, part of innovation. If you are looking for research direction, then look at for what catalyst, from dehydration and polymerization to long chain. So ethanol is 2 carbon, right? And jet fuel is 14, 15, 16, 12 carbon. So you are building chain. Dehydration, joining. It's more on catalytic research and plus combined by distillation. So the researcher will focus on catalyst development in that area. And then the focus, if you want to go, lot of industries moving towards electrochemical reaction processes. So that's another promising down the line 15-20 years where we want to move thermal processes to electricity. The reason is renewable electricity is getting cheaper, availability, energy storage is getting better. So why to rely on burning or conversion? Why not electricity? So the future state of art, I said that, and the down the line roadmap you can say SAP, marine, electrochemical processes, electrocatalysts. These are the direction you want to do, which is the, to me, it looks like another 5, 10 years, 20 years in that direction.
Because always we think of transport sector, biodiesel and all. We never think of jet fuels.
Yeah, but for biodiesel, how much will last you? Can you imagine? If we started putting charging station in next 5-10 years along, you will see lot of explosion of electric vehicle. You already see scooters and auto and all. So once you move to electric, who will take biodiesel? How much can you take? The another biodiesel is very well, but the reason is it's a blend fuel. You will not see cars running on 60-70% biofuel, 10 or 20%. So you limit yourself. But if you have a renewable diesel, you're going, and aviation has no answer yet. If you look at the research, GE or all top companies, they are doing electric aeroplanes. Lot of, but we are close to our lifetime or maybe other part of life. Marine, same thing. It's a huge ship. You will see that. And fuel requirement is a lot. And fuel requirement is little bit different because aviation has different requirement, and this is shipping, water side has a different fuel requirement. Okay, so these two fuels are picking up, and we should focus on that, how much we can contribute.
Sir, we said about 2 different processes. Anaerobic digestion process, another one is aerobic digestion process. In anaerobic digestion process, it is without air, about 45% CO2 is generated. But aerobic process, it is with the atmosphere. What is the percentage of CO2 there, sir?
In aerobic, you are losing carbon in form of CO2, right?
Yes, sir.
You are supplying. Our idea is if you want to make fuel, you want to preserve carbon. That's where anaerobic comes, where you have methane. Okay, and there you will see 60-40 ratio. Average I am seeing it maybe 56-62 also, depending on what we just talk and condition. So that's for biogas, and aerobic is not done for biogas. No, okay, it's for more construction and other things. Again, I want to add on biogas also. We are moving to biogas vehicles, CNG and all, but transition is how to go to liquid fuel. The processes are there, lab scale. When biogas, people have tried to change it to diesel. CH4 plus CO2, that's what you get to clean it up. CH4 conversion CO2 catalytic, people are looking at that. At high temperature, CH4 plus CO2 is converted to syngas using dry reforming process, 600 700. People are looking at how to bring it down. So imagine you are looking at biogas coming from digester, CO2 plus CH4, and if you have some catalyst at low temperature, photocatalytic or something, just you can tune that CO2 to CO. You got an opportunity to change into liquid fuel because CO2 does not burn, so you will get more carbon efficiency. So again, that's the direction. If you are working on digester, let's focus on how to change CO2 to CO. That's another way.
Just I was comparing the CO2 emissions on both processes. So around 45% in anaerobic. What is the percentage up to 50%?
And they are not looked at aerobic what they do because they focus on biogas and all. And aerobic will definitely be less methane, so emission will be less because methane is more potent.
Because somewhere when we are writing the research papers, we are comparing the carbon dioxide emissions to the atmosphere.
Yeah, definitely. So in aerobic, anaerobic means absence of oxygen. So you are preserving carbon in methane, which is more potent. If you emit, if you need fuel, then you need that. Aerobic means you are oxidizing carbon so that it does not go to CH4. So their emission will be less even if you leave it. If we are doing composting, we are preserving methane emission, right? If you don't do composting, then things are going to degrade and contribute to it. So composting helps at the lower level, our community level. Biochar helps further. If you do biochar, you do much more than that. Any more question?
Purity of methane. If it is not pure, it will produce more greenhouse gases. So how to deal with that problem?
Pure means you will get pure ethanol from fermentation, right?
Fermentation.
When you blend with petrol, you are blending. So I don't think purity is a question.
But most of the people they do talk about purity of the ingredients. So that is like
That's
part
like formal language may be talking, but what I said that the ethanol has lower heating value. So energy value coming down, that might be talking. So it's reducing the efficiency, other thing they may be showing how much you have to do. Okay, that might be the reason. Purity in fermentation, typically biochemical process is much purer than
It's not a great difference. Heating value is not a great difference when we add the ethanol. Not a great difference.
you are adding only 5 or 10% return.
Yeah, up to 20% it's okay.
No, you simple math. One is 44, another is 30. So you do 95 into this and 5 into this. It will reduce, but it may not reduce a lot. When you start adding more, then it will compose. Yeah, so at 5%, it will be little less impact than the other.
Now, government allows around 10%.
Yeah, 10% in United States also is 10. Here it allows, there it is mandatory. So the difference is, if you make mandatory, you will be filling up. Right? If you allow, then I have a choice, take it or not. Then it comes the question, someone thinks it's not pure, so I will not take it and other things. But if you make mandatory, you will take it. Yeah, the heating value is simply how much you blend, just equations you can put it percentage.
Good morning, sir. Sir, what is the future of advanced biofuel like second generation and third generation biofuel in India?
In India is doing a lot on biofuel, right? That's what we are talking. Ethanol is coming up. Raj industry is working a lot on grass and bagasse to make it. Maharashtra belt sugar in bagasse going focused on ethanol. So good future is there. What I'm saying is that down the line, if you can produce ethanol can be made through jet fuel also. Government supports it a lot. I see a lot of programs coming up, National Bioenergy Program and other things. So investments are going on.
Sir,
It's a
Raj,
big-
Raj is the best example of startup.
Yeah, Raj. And I showed you that bioenergy, NTPC, Ministry of Power mandated 5%. You think 5% is a small amount? Is not. You take 1,000 ton per day coal, and 5% of that, that much biomass you have to add, you will struggle to secure within 15 kilometers. You may not have that much. So it's a big change, big boost for torrefaction and bioenergy. You can TPC and other start putting 5%, and they are planning to make it to 7%. So a lot of business opportunity came, right? Rural sector where all these feedstocks are left over or have low value trading and other application. Now you supply to NTPC or any other power plant, you get pricing on that. So it's a business opportunity, job creation, local. The good part of bioenergy or biofuel is local job creation.
So both the cost beneficiary comparative to diesel and petrol, the production of ethanol.
Ethanol, again, ethanol is good for blending 5-10% and that. But how, if you want to go make a bigger impact, you need to go 100%. Right? Biofuel, I'm not talking ethanol. If you want 100% biofuel, then you want some fuel which is directly go to pump and pump, no blending. Okay, that's why I was saying advanced biofuel or SAF, sustainable aviation fuel or marine fuel. So ethanol is doing good and it will keep doing good, but we want transition further, not 5 or 10 or 20%. Complete change.
So you continuously mentioned that these are business opportunities, entrepreneurship opportunities here. So, but what would be the investment and what is the kind of the labor that would be required?
Yes.
Like, what would be the monetary investment on these projects? Be it
If I dare, I look at a startup India schemes what they have, right? Proposal, look at the build a team who builds technology, who lives business, who can look at all these things. Build a team, put a company, government, and under this guidelines, Ministry of Power, you connect with them. My startup is going to support this. You have a better chance. So a startup is technology plus business. How much you can make it, not just technology, right?
So you were talking about these projects could be implemented in rural areas as well. But if we required a skilled labor, I'm not saying
Yeah, I
that
get
the
it.
labor there is not skilled. We can teach them. But initially, how do we take up the project?
So I'll really tell everyone, look at Husk Power story. How they, this is one of the early success stories, that's why I'm saying it's nothing to do with Innova or not. Look at their success story, how they did. These two guys were from, happened to be Bihar, but they were in US. One is electrical engineering, another I don't remember. They came back just seeing this opportunity. And they built the empire in that sector, and now they are great supplier to African countries. So they came with business idea. It didn't matter, they didn't know biomass, they are electrical engineers. But they see that this is the gap and we can do that. So business or a startup requires open mindset, not just lock down the research questions only. Move on. So what I'm saying here is 5% torrefaction, and someone can reduce the cost and supply at a lower cost to NTPC or whatever company, and they have a business case. Right? Come with some other feedstock which no one has seen yet, and you have a kind of guaranteed security that you will get that. One of the big challenges is biomass securing feedstock. This year you can get, next year it may change, price may change, and then you have an agreement for let's say $100 per ton. Next year it is 120 because weather difference. So these are the challenges. Looks simple, but then building a plant to feed a crop. Then transportation comes, logistics comes, farmers come, policies come, regulations come. So it's a different, but entrepreneurship interest. If we have little bit, these are the opportunities. And wherever training and other thing comes, you can definitely train them. They are running a plant will be run thousands of plants, right? Different chemical sectors and all of this. All these processes are either running fermenter or those pyrolyzer or gasifier, right? And some catalyst. If you are given training a week in Manipal, you will run that pyrolysis. It's not big deal, so you can train that. Nowadays it's more automation. So you have a centralized control system where you watch and let them run. AI, ML, especially AI has solved many problems.
So, like Jalgaon, Maharashtra, even some part of Rajasthan, they are growing napier grass.
Yeah,
This is the best source of
bioenergy.
biomass.
How many of you remember Jethropa? Like you remember, right? It came big for biodiesel, and Indian Railway started doing that diesel injection. The problem came, can we grow so much to get Jethropa? And it turned out to be the seeds were fine, but it was cakes and all were toxic. So you could not give it to feed animal feed. So then what would you do? So you are looking at the doing processes. So the process of conversion was not a challenge in Jethropa. The challenge were growing, its toxicity, handling and other things. So technology is not always a barrier. This is the entire life cycle. I remember many growing big Jethropa farms in African countries. They secured land and it came big but faded away. LG also have very good opportunity if you are working in there, because LG will give you proteins, oil, and that oil can directly go to jet fuel. You don't have to do pyrolysis oil and then upgrade and all. You can directly do conversion to that. There are companies which are working on how can modify biologically LG, which can give directly long chain hydrocarbon.
Mostly there is Arizona.
Arizona is a big Department of Energy bed there. LG to add, they call it HCAT, big farm. So LG brings a lot of opportunity. Macro LG also coming up, a lot of opportunity with that.
What is your comparison opinion about us and your department student as how we see biomass as a fuel?
So we are going out of Jan. So comparison about
Us and your student in your department,
so
how we both see biomass as a fuel.
biomass as a figure.
What is our approach comparison to that?
There are a lot of things here going on. I see much more energy here than I yeah.
We don't have agriculture.
There's a lot of what is fine, yeah. And many of my our students are from here only. They are either from here or other universities. So, and I'll tell you, PhD or down the line thing is, if you like it, then only you do PhD. You like the field. So any student either here or there, they like that topic. That's why they will do. Otherwise, there is enough job outside. Why you put 4 or 5 years of PhD, which you may not like it. Right? Just degree does not give you anything. If you are PhD, then you know the topic, then only you get a good job.
Any other questions?
If not, then thank you everyone. I'm still around next few hours. Making products, renewable products. Utilization means you are making methanol or some products. What technology is used to capture CO2 directly from atmosphere? DAC, right? Direct air capture. What is a common product made from captured CO2? Anyone? We have CO2, what common products we can make? One I just discussed. Company name was IOCL or something, CO2 to methanol. And if you remember Fischer Tropsch, you can keep building longer chain and alcohol, so you can make ethanol of it. So these two can be made. Methanol, even methane also, so A and B. How does CCU support renewable energy integration? How does CCU support renewable energy integration? You utilizations you capture and you can integrate with energy storage. Batteries and all, right? So by utilizing excess renewable energy to power capture processes. So any capture process you can integrate with electricity. What is the role of hydrogen in synthetic fuel production? Yeah. Which of the following is the benefit of using synthetic fuel? They are cheaper than conventional fuel, they reduce greenhouse gas emissions, they increase energy efficiency, they are less efficient than conventional fuel. Synthetic fuel they reduce greenhouse, that's why we go renewable, right? We talked this one few minutes back. What is the main difference between CCS and CCU or CCUS? S is just for utilize. So basically by utilization you bring some economics right away. Just a store means you spend money, but here you have some byproduct. What is the key application of captured carbon in construction? Concrete making. So CO2 you can capture in concrete. So low carbon, what is that? Carbonated building materials. And it captures for long time concrete. Right? You build a building, then CO2 stays long time. True or false? Carbon capture and utilization involves storing CO2 underground. If it is S, then it is okay, but it is U, so you are not storing. Synthetic fuels are made from captured CO2 and renewable hydrogen. Yes. CCU does not support economic growth. False, right? Carbonated building materials is again repeated one, are more durable than traditional materials. It is said that, but not proven, so I will say false. CCU is a substitute for carbon capture and storage. It's wrong, it's U. The same thing, carbon capture utilization involves converting CO2 into only one product name. Primary purpose of CCU is to reduce greenhouse gas. Carbon capture supports renewable energy integration by utilizing excess renewable energy to power maybe power plants or something like that. Yeah, something missing here. Captured CO2 can be used to produce renewable fuels like ethanol and ethanol. The main difference between CCS and CCU is that CCS focuses on storage while CCU utilizes, and if you make CCUS then utilization and sequestration or storage. Captured carbon is used in the production of low carbon concrete materials or something like that. These are simple questions, might be confusing by words, but you should be able to answer.